You have done this 1,000 times. You open your browser, type chatgpt.com, hit enter, and few seconds later, it's just there. The page loads, you start typing, it feels instant, it feels simple. But here's the thing, in those few seconds between you pressing enter and that page appearing on your screen, something absolutely wild happens. Your request leaves your laptop, travel across the internet, bounces through multiple systems you have never heard of, reaches a server somewhere in the world, gets processed, and then the response races all the way back to you. And it all happens under a second. Today, we are going to follow that journey, every single step. By the end, you will never look at a loading screen the same way again. Okay, you hit enter. Your browser wants to connect to the chatgpt.com. Simple enough, right? Except your browser has absolutely no idea where chatgpt.com actually lives. It knows the name, but the internet doesn't work on names. The internet works on addresses, specific numerical addresses. Like how knowing someone's name doesn't tell you where their house is, you need their actual street address to get there. So before anything else can happen, your browser needs to find chatgpt.com address. And to do that, it's going to ask for directions. There is a system called DNS, the domain name system. Think of it like the internet's phone book. You give it a name, it gives you back an address. Your browser first checks its own memory. Did I look this up recently? If it did, great. It already has the address. But if not, it reaches out to a DNS server and asks, hey, what's the address for chatgpt.com? The DNS server look it up and replies, here it is, a string of numbers called an IP address. Something like this. That's where chatgpt.com actually lives on the internet. Now your browser has an address. Now it knows where to go. All right, your browser has the address. You would think it just goes there, right? Knock on the door, say hello, ask for the page. Not quite. Before your browser can send a single piece of real data to chatgpt.com's server, the two of them need to shake hands. This is called the TCP handshake, and it exists for a reason that actually makes a lot of sense. Imagine you are about to have an important phone call. Before you start talking business, you say hello. They say hello. You confirm you can both hear each other. Then you start the actual conversation. That's exactly what TCP does. Your browser says, I want to connect. The server says, got it, I'm ready. Your browser says, great, starting now. Three messages, half a second. And now they trust each other enough to actually communicate. Here's where it gets interesting. Your browser just shook hands with the server. But how do you know it's actually ChatGPT.com server? What if someone in the middle intercepted your connection and is pretending to be a ChatGPT.com? This is a real threat. It's called a man in the middle attack, and the fix is something called TLS or HTTPS, which you have definitely seen in your browser's address bar. Before the real conversation starts, ChatGPT.com server shows your browser a certificate like a passport. A trusted authority has signed this password and says, yes, this really is ChatGPT.com. Your browser checks the signature, confirms the password is genuine, and now, only now, the real encrypted conversation can begin. Everything from this point forward is encrypted. Nobody in the middle can read it. Okay, handshake done, identity confirmed, encryption set up. Now your browser finally sends the actual request. It packages up what you want. Please give me the chatgpt.com homepage. Wraps it in something called an HTTP request and sends it off. But here's the thing, chatgpt.com isn't one server sitting in a room somewhere. It gets millions of requests every day. Now, single server could handle that? So, no single server could handle that. So, before your request reaches any real server, it hits something called a load balancer. Think of a load balancer like a traffic cop standing at an intersection. Hundreds of cars are arriving every second, all trying to get to the same destination. The traffic cop's job is to look at which lanes are free and direct each car to the least congested one. Your request arrives. The load balancer looks at all available servers. Server A is handling 847 other requests right now. Server B is a bit lighter. Server C just finished a batch. It sends your request to server C. You never knew any of this happened. To you, it just load. Your request lands on a server, and now the server actually has to do something with it. For a simple web page, it might just grab some files and send them back. But ChatGPT.com isn't a simple web page. When you send a message to ChatGPT, the server has to run your text through an enormous AI model to generate a response. We will get to what that actually looks like in a second. For now, the server processes your request. It might need to check a database. Are you logged in? What's your account? What's your conversation history? It goes and fetches all of that. Then it starts preparing what to send back. Here's the part most people don't know. When you ask ChatGPT something, the response doesn't exist yet. It's not sitting in a database somewhere waiting to be retrieved. The model generates it, word by word, in a real time, based on everything it learned during training. This is why ChatGPT streams its response to you character by character. It's not pretending to type for dramatic effect. It literally doesn't have the next word until it's generated it. Each token, each small chunk of text gets sent back to you the moment it's ready, instead of waiting for the entire response to be finished first. And that streaming response travels back through the same route it came in, through the server, out to the load balancer, back through the encrypted connection, across the internet to your browser and onto your screen, word by word in real time. The response is on its way back. It retraces every step out from the server, past the load balancer, back through the encrypted tunnel, across the internet, through your Wi Fi router to your laptop into your browser. Your browser receives those streaming chunks of text, renders them on a screen as they arrive, and from your perspective, it just appears smooth, instant, like magic. It's not magic, it's about a dozen different systems all working together in under a second. Let's name everything we just saw. DNS. Translated the name chatgpt.com into an IP address your browser could actually use. TCP. Established a reliable connection between your browser and the server. TLS. Verified the server's identity and encrypted everything. HTTP. The format your browser used to ask for the page. Load balancer. Distributed your request to the right server out of many. The server processed your request, talked to a database, and prepared the response. And for ChatGPT specifically, our large language model generated the response token by token, streaming it back in real time. Seven things, all happening in sequence, all in under a second, every time you hit enter. Now, here's why this matters for you specifically if you are learning software engineering or preparing for a tech interview. Every single one of those components we just named DNS, load balancers, TCP, TLS, databases, distributed servers these are the building blocks of system design. Every design a system like Twitter or design a URL shortener interview question is just asking you to think through how those same pieces fit together for a different problem. You just watched a real system, one of the most complex on the internet, do exactly that, and now you have a mental model for it. The next videos in this playlist go one level deeper on each piece, but the map, you already have it.